We have not this entire year reviewed for a quiz. Took in a day and review. We always do it for a test, but never for a quiz. And you know what? We're not going to the rest of the year. All right. We specifically review for this quiz because there's a lot of new info on there. Okay. And I want to just make sure we can take a step back. I'm going to review Hills and SAS with you right now, special right triangles with you, and then Pythag. And then I have 2 questions from your packet. All right. What are the resources that are available between now and this time tomorrow for you to try out? Everyone's on page 22 of your packet. That contains 7 questions. Everyone see the top of page 22. Textbook questions. And to go even further, on Aspen under our Unit 8 folder, I put a file that has Hills and SAS questions and a file that has 30, 60, 45, 45, 90 questions. Okay, so a lot of problems out there for you guys to try. So you don't need to email me. Can you send me this? I put it all on Aspen instead. Okay? All good about tomorrow? Okay, it's going to come strong. Let's first start reviewing Hills and SAS. If you want to write this down, if you rather just focus and soak it all in, I don't care. Whatever you guys prefer. Okay, Hills and SAS. Got to have a specific type of diagram. The original triangle. The big triangle has to be, oh boy, a right triangle. That's this whole unit. What else needs to be drawn in for you to be able to use Hills and SAS? Altitude. All right, well, there's 3 in every triangle. Where's this altitude have to start from? There's 3 vertices. The right angle and be drawn to the hypotenuse. That is automatic Hills and SAS. Altitude to the hypotenuse. I get fired up thinking about it. Do not do the following tomorrow. Because I'm warning you because I see it every year. Do not put in degree measures that are not there. Oh, well, that's a nice diagram. Hey, that's a 45-degree angle. Oh, is it? All right, is it? That's a 45-degree angle. No, it's not. Okay? If you don't know for sure mathematically that it's a certain degree measure, don't touch it. Because odds are, if you find yourself putting in 45, 30, 60 tomorrow, it's probably a Hill-SAS question, and you just don't know it. Okay? Do not put in your own degrees tomorrow. Everybody good? All right. That fires me up, obviously. All right. My goal right now is to rattle one of you. I'm going to rattle one of you right now. I'm going to get a number, call out a segment, hypotenuse, leg, segment, altitude. You tell me what the deal is. We ready here? Here we go. Here we go. I'm already in some of your heads. I'm already there. 15, AB. Good. Can't rattle you ever. 5, DC. Wow. Quick. 7, BD. Good. Who told me that? And you weren't even sorry about it. Good job, Ella. Good. You're learning. 1, AC. Whew. You guys are legit right now. You're legit. Don't screw it up. 6, BC. 15, AD. Good job. There they are. They're all my labels. You're not off the hook yet. Explain to me this Hills business. How does this work? How does Hills work? 5, H, L, L, S. Didn't even have to use any follow-up questions there. Unbelievable. Thank you. Good. I don't have anything else to say. Anybody else? Questions about that one? No jokes, no nothing. All right, what's the deal with the SAS? Learn from Sydney there. 8 S A A S. There you go, kids. Be prepared tomorrow. You might want to use hills, but you can't find the hypotenuse. So you might have to use SAS to get it. Okay, so a two-parter. All right, all in one. Be ready for that tomorrow. This is coming strong. Also tomorrow, you might be able to set up hills, cross multiply. Uh-oh, going to have to factor. Uh-oh, going to have to use quadratic formula. It's there. All right, I don't have to warn you guys anymore, but I am. You guys still have your formula sheets from similar triangle unit. Bring them tomorrow. Bring them. You may need it. May need it. Questions from you guys? Hill SAS going? Pythag. Highly doubt I'm just going to have you guys use a squared plus b squared and c squared and find the side, right? Highly doubt that, basic. What did we use Pythag for? To tell if a triangle was obtuse, acute, or right. All right, here we go. What if you do a squared and b squared and those legs, that value turns out to be bigger than the hypotenuse squared? What am I working with? That's an acute triangle, yep. And then if the legs are smaller than the hypotenuse, that'll be a obtuse. And if they're equal, that's a right triangle. That's Pythagorean theorem. I give you 3 values, 3 side lengths. How are you going to know which one's the plug-in for A and B? How do you know their legs? I give you 3 numbers that represent side lengths, and I want to know if it's an obtuse, right, or acute. Which ones do you plug in for A and B? So for instance, radical 6, 2, and 3. Which ones do you plug in for A and B? The 2 smaller ones. You plug in the 2 smaller ones for A and B, and C is the bigger one. Good there? All right, also what we did with Pythagorean theorem. In your notes when we did Pythagorean theorem, remember we did this hardcore algebra one? I think it was 8, x plus 4, and x. And I said solve for x. And then in homework, you guys did this one. X plus 5, and 25. Find the value of x. All right, that could be 1, 2 tomorrow. Are we going to have some self-respect when you do that tomorrow? Are we? Are we? What am I asking you to do there? There you go. Do not, you pull this. Whoo, buddy. Fuming. All right, all set there? I believe in the notes, remember when the x squareds canceled out on both sides? That's this one, and then this one was, I think we used quadratic formula or factoring to figure out that one. Pythagorean theorem, all good. And then finally, what we just spent the last 2 days talking about, which was I already went over this in the homework. Anybody got my 30, 60, 90 rules for me? 3, got my 30, 60, 90s? Perfect. There you go. And don't be surprised tomorrow if it's a combo problem. What do I mean by a combo problem? What are you spouting off, Alex?
This one, there's both of the kinds of triangles in one diagram.
Oh, you think so?
Yes.
Yeah, they're right there. Quiz number 1, right there. Go ahead, hack into my Google Drive. You got it. You earned it. There you go. like you did for homework right there. Where the triangles, one of them could be a 30-60, the other could be a 45-45. There you go. There's another one that we did on page 16. So that's, yes, Alex, you are correct. Okay, so that's what I'm talking about. Any questions? Any questions before we try a couple on our own here? Oh, last thing I got to tell you, which might be the most important thing about tomorrow. Mr. Big Al will be present on the quiz tomorrow. Okay, so I know that's an important fact for you guys to know. All right, he will be making an appearance in one of the 9 problems. Okay. All good? You ready to do one of these? Okay, page 22 of your packet, number 1. Calc's ready to roll. Calc's ready to roll. Gonna need it here. There we go. We got the airport, the factory, and the shopping center. What a nice little town. Airport and the factory, 6 miles apart. Got it. 6 miles apart. And their distances from the shopping center are 3.6 and 4.8 respectively. When they say respectively, see how in the previous sentence it said the airport and that came first? So that always goes with the first number when they have respectively, just a little FYI. So airport and shopping centers 3.6 and 4.8 for the factory. And guys, if you mess those up and flipped them, it's not a big deal. It's not going to affect the problem. But if you threw the 6 somewhere else, that would. And what are we looking for? I got this service road, which is right here from the shopping center to the airport and factory. Okay, get in the mind right now before I write down anything, any numbers down. What type of problem is this going to be? Do you see any degree measures other than 90? So don't write any more in. Hey, angle F looks like it's going to be 45. Well, it also looks like you're not going to do very well then. Okay? Sorry. All right? Don't write in angle measurements that aren't there. So this is not a 45 or a 30-60, but it is a Hills and Sass. Hills and Sass. What's X? Altitude. Only one that involves altitude, right, is Sass. But there's an issue. Shocker. We got an issue in honors. All right, I can't do this right away. Why not? I don't have any of the segments. Any of the segments. But what could I break out that may help me find a segment? Hills. That's got an S in it for segment. Here we go. Help me find one of the segments. Who's up on this one? 17. Here we go. Hypotenuse. 6. Leg. Patrick could have also picked 4.8. That would still have been correct. Leg. Same leg you use, yep, whether it's 3.6 or 4.8. And then S, I'm going to call Y because I've already used X as my altitude. So, okay, there we go. No factory needed here, kids. How long is that segment adjacent to 3.6? 19? The one we're solving for now, adjacent to 3.6. What's your deal?
What?
You,
I was just not. So the segment adjacent to 3.6
correct.
is, do this label it. Well, I solved it as 2.16.
Is that this segment? Okay, that's all I needed to know, Maya. We good? Okay. Thank you for making it a little more awkward now. Yeah. 2.16. Hey, honors kids, do I need to do hills again to find the other segment? No, you don't. You can if you want. Sure, it's not going to impress me, but how can I find the other segment? Subtract it from 6.0, and what's that one? 3.84. And now I have my two segments. So I can go back to SAS and say 2.16 over x equals x over 3.84. It says round to the nearest hundredth, but it's going to come out to the nearest hundredth anyway. There's no need to round. Oh boy. 4, what do you got for me?
2.88 miles.
Wow. And units. What a boss. Thank you. I didn't even have to remind you. There you go. You proud of your boy, Isaac? Didn't even need units there. We all good? Typical Quiz Hill SAS question. You need some. You can't solve for it right away, so I need to go to the other one to get a piece. Bless you. All good? Number 5. Number 5. Two reasons why I'm going to do number 5 with you. 2 reasons. Number 1 is it's slightly difficult. All right, it's slightly difficult. And the second reason, probably the most important reason, that this problem uses the word snuggly in it. So why not? Okay? It's not loose. It doesn't fit perfectly. It's snuggly. All right? That's a key to the problem, snuggly. All right. And it's a box of chocolates and Valentine's Day on Friday, so there you go. I guess it's pretty close. Regular hexagon from our days in polygons. Regular. Okay, all sides and all angles. Okay, good. And each side is 3 here. So that means all the sides are 3, wherever you want to put the 3. All sides are 3. And what type of box is this hexagon placed in? Rectangular, and that's huge because what are the angles? 90 degrees. So I at least have a 90-degree angle where at least I know the hypotenuse is 3. Whew, this is looking like one of the special ones. But I don't know for sure if it's a 45, 45, or 30, 60, or maybe neither. Is there a way I can find one of those angles? Can I find one of those angles? Remember, a regular hexagon. Anybody remember how to find all the angles? Little formula. 180 times n minus 2. 180 times 6 minus 2, 6 sides. So there's 720 degrees, but you just want one of the angles. So take 720 and divide by 6. One angle inside the hexagon is going to be 120. That's, hey, take a look. That's inside. What about the one next to it? 60. All right, what type of triangle am I looking at? Okay, before we move on, everyone just stop for a second. Are we okay on where the 30 and the 60 are coming from? All right, in all seriousness, because I know a lot of people don't know this, when they ask for what are the dimensions, what they're looking for, they are looking for the length of the rectangle and the width. So they want to know those 2 lengths when they ask for the dimensions. What are those 2 segment lengths? Okay. All right, so here we go. It's a 30, 60. 30, 60, 90. I've asked somebody already. X radical 3 and 2x. I know a side length is 3. Where do I put the 3 in the chart? Where do I put the 3 in the chart here? Here you go, 17. Where am I putting the 3? Under the 90. Perfect. Okay, I need the other two, though. What's across from the 30 then? Going backwards. What's across from the 30? Oh, 11s. 1.5. How'd you get it? Just divided by 2. And then what's across from the 60 now? 8. Perfect. Okay, so let me go back to my diagram. Let's see what color I have. Okay, so across from the 30 was 1.5. Across from the 60 was 1.5 radical 3. What's this side length going to be? Do I have to do this all over again? No, it's going to be across from the 60. What was across from the 60? Can you add those two together and let me know what one dimension is? 1.5 radical 3 plus another 1.5 radical 3. 2? Darn right, boss. 3 radical 3. All right, what about the bottom part now? What's this part going to be? 1.5 as well. But be careful when you add them up. Be careful. What's that bottom length going to be? Oh, 1. 6. 1.5. Don't forget about the 3 and the other 1.5. So 3 radical 3 by 6. Or you could go 6 by 3 radical 3. Doesn't matter what order you put the lengths. And still missing something? Inches. Nice problem right there, huh? Beautiful. Geometry. Love it. Anything from you guys? You got 7 problems. You got book problems. You got 2 sets of questions on Aspen. Whatever you want to go to, go ahead. We got a solid 14 minutes here. All of these answers, textbook and packet, are all on Aspen under the homework folder. All right, please make sure you look there because they're not in the packet. All right, they're all under the homework folder on Aspen.